Number 7, here we have given matrix A is equal to 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. Verify that A into adjoint of A is equal to adjoint of A is into A is equal to det A. Det A, they have given this symbol. Instead of writing det A, they have given this symbol. Remember, I told you that you can give this symbol also. Is equal to det A into I. Okay.
Yes, sir.
So the the first thing that we are going to do here, we are going to find out the adjoint of this matrix. Adjoint of A. Okay. So you have these positions,
Okay, sir.
plus, minus, plus, minus, plus, minus, and plus, minus,
Nine,
plus. So the
nine.
with a plus sign, the minor of 1 will be 2, minus 3, minus 1, 3. Then with the minus sign, you have 1, minus 3, 2, 3. And then again with the plus sign, so this is a plus position, the minor is 1, 2, 2, minus 1. Again here with the minus sign, the minor here is 1, 1, minus 1, 3. Again with the plus sign, the minor here is 1, 1, 2, 3. Minus sign, the minor here is 1, 1, 2, minus 1. Again with the plus sign, you have 1, 1, 2, minus 3. With the minus sign, you have 1, 1, 1, minus 3. Okay. And again with the plus sign, you have 1, 1, 1, 2. And not only this, but the transpose of all this. This is your adjoint. So let us now find the values of these determinants. You have 6 minus 1 into minus 3. That means 6 minus 3, which is 3 with the minus sign. So minus 3. Next you have 3 plus 6, which is 9, which is minus 9. You have minus 1, minus 2, minus 4, which will give you a minus 5. Then you have 3 plus 1, 4, with a minus sign, minus 4. 3 minus 2, a 1. And then you have minus 1, minus 2, which is minus 3. And minus of minus 3 is plus 3. Minus 3, minus 2 is minus 5. Okay. Minus 3, minus 1 is minus 4. 2 minus 1 is 1. All this transpose. Now we find out so the resulting adjoint is minus 3, minus 9, minus 5, minus 4, 1, 3, minus 5, minus 4, 1. Okay. So we have to verify that A into adjoint of A is equal to adjoint of A into A is equal to det A into I. So first we find the product A into adjoint of A. Therefore A into adjoint of A. See what is A into adjoint of A? A here is 1, 1, 1. And 1, 2, minus 3. And 2, minus 1, 3. And the adjoint that we have found out here is minus 3, minus 4, minus 5, minus 9, 1, minus 4, minus 5, 3, 1. So multiply these two. If you multiply, you get 1 into minus 3, which is minus 3. 1 into minus 9, which is minus 9. 1 into minus 5, which is minus 5. First row, first column. First row, second column. Minus 4, minus 1, plus 1, minus 4, plus 1, plus 3. Check the multiplication, okay? Minus 5, minus 4, plus 1. Minus 5, minus 4, plus 1. Minus 3, minus 18. Okay, second row, first column. Minus 3, minus 18, plus 15. Next, second row, second column. Minus 4, plus 2, and you have minus 9. Okay?
Yes, sir.
Minus 4, plus 2, and minus 9. Next, second row, third column. So you have minus 5, minus 8,
Okay.
and minus 3.
3.
Next, third row, first column. So you have minus 6, plus 9,
Plus 9.
minus 15.
Minus 15.
Next, third row, second column. So you have minus 8,
Minus 8.
minus 1,
Minus
plus
1.
9.
Plus 9.
Okay, and then you have minus 10. Third row, third column. Minus 10,
10.
plus 4,
Plus 4.
plus 3.
Plus 4. 3.
Now, just add these. 8 and 6 is minus 17.
Yes, sir. 0.
And this you have what? 0.
0.
And this is again
So minus 8.
minus 8. Sure.
Yes, sir.
First row,
Minus
third column. Minus 5, minus 4, plus 1. Okay. It should not be actually. Have I made any sign mistake? Just let me check once again. We have, after correcting the signs here,
14.
what we have here is 3 minus 14 is minus 11. Okay.
Minus
And
11.
here you have 0 or not 0.
0.
Yes, 0. And here again you have a
Yes,
0.
here also
Okay. And
0.
here again you have a 0.
0.
And here again you have minus 11.
Minus 11.
And here again you have a 0.
0. 0.
And 0, 0, minus 11 again. Okay.
Yes, sir.
This is what you have. So A into adjoint of A. Now you multiply adjoint of A into A. Okay. I keep this as your exercise. Okay. Check it. You will get the same. Adjoint of A here is 3 minus 4. 3 minus 4 minus 5
Minus 5. 9.
minus 9
Minus
1
9. 1. 4.
4
Minus 5.
minus 5 3 1.
3. 1.
And the matrix A here is 1 1 1 1 2 minus 3
1 to 1 minus 3.
1 2 minus 3, and the third row here is 2 minus 1 3. 2 minus 1 3. Okay,
2, 3.
so this, check your multiplication. Okay, you will get the same thing. Minus 11
Okay.
0 0
0.
0.
0.
You actually multiply. Okay, when
0.
you're doing in your copy, you actually multiply and check. Okay,
Okay, sir.
you will
Minus
get this matrix only. So I have checked here A into adjoint of A. I have done the multiplication. Okay, adjoint of A into A. I have done the multiplication.
yes, sir.
Now what is left? Det A into I. So first we'll find determinant value.
Data into I.
Yes.
Data
Det A here is, check what is the determinant. Determinant is 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. Okay, now find the value simply. Expand the determinant. So this is your plus minus plus position. So plus 1 into this 2 minus 3 minus 1 3. Next is the minus position. So minus 1 into this next minor is 1 minus 3 2 3. And then again your plus position 1 2 2 minus 1. 1 into 6 minus 3. Okay, minus again 1 into 3 plus 6
3 plus
plus 1 into minus 1 minus 4. Okay, minus 1 minus 4. So you get 1 into 3, which is 3, and then minus 6 plus 3, 9 into 1 is 9, and then you have a minus 5. Okay, so you get minus 11. Data you are getting minus 11. So therefore, what is data into I? Data, or better still, they have given they have not written data, they have given this symbol. Okay, for data. So I better write this symbol, data into I. Here also change this symbol. Instead of writing
okay, sir.
data, you give this symbol, same as data. Okay, so data into I is minus 11. And what is the identity matrix of order 3? 1 0 0 0 1 0 0 0 1. Okay, so when you are multiplying, you will get minus 11 0 0 0 0 minus 11 and 0, sorry, 0 minus 11, 0 minus 11 0,
Okay, sir.
and you get 0 0 minus 11. So if you see, what was adjoint of A into A? A into adjoint of A was this matrix, right? Adjoint of A into A,
Yes,
if you
sir.
multiply and check, you will get this matrix. And
Minus
also, data
minus 7.
into
Yes,
I
sir.
that you are getting the same matrix. Hence,
Same matrix.
A into adjoint of A is equal to adjoint of A into A is equal to data into I. That is verified. Okay, so this finishes your problem. Any other problem worth doing? All the others actually you can do on your own. But what I would like you to try is this problem. This one, number 9. Here it is said, show that adjoint of A is equal to thrice of A dash. A dash means A transpose actually. Okay, I told you transpose is also denoted by A dashed. So
It has.
you can do this, right? It's not too difficult. Find the
Yes, sir.
adjoint of A and check, take the transpose of A and check whether both sides are equal, both matrices are equal. Okay, so try this, just one problem from here.
Okay, sir.
For
Okay,
practice
sir.
sake, just try one. Okay, and this is what I think. This should be all. This, you want to practice more problems, you're always welcome, but this is the minimum that you can do.
Okay, sir.
Let us try the next exercise. This is a more important exercise. This one, 2h. Okay, now what I want you to try first is, here, find the inverse if this exists. You can find the inverse of a 2 by 2 matrix, right? So you try this problem.
Yes, sir.
3 part 6, you try on your own. Okay, find the inverse and adjoint of the following. Yes,
3 part 6.
yes. Okay,
Okay, sir.
I'll do here number 1, this number 5 I'm going to do. Okay,
Okay, sir.
5a. Given a is equal to 2x 4 2, x not equal to 1. Calculate a square. So we calculate a square. A square is very easy to calculate. A square is equal to a into a, which is equal to 2x 4 2 2x 4 2. Multiply these two matrices. First row, first column, 4 plus 4x. Okay. Next, 2x plus 2x, which is 4x. First row, second column. Next, second row, first column,
Okay, sir.
8 plus 8, 16. And second row, second column, 4x plus 4. That's what. Okay. What you can do is, you can take out 4 also from here. If you take out 4, what are you left with? Before taking out 4, what you can do here is, you can take 4 common from this. 4 times x plus 1, 4x, 16, 4 times x plus 1. So now you take out 4 x plus 1, x 4 x plus 1. So this is the matrix that you are getting, a square. Okay, now we proceed to
Okay,
find inverse of a square. What is the second one?
sir.
Second one is a square inverse. Okay,
Square inverse.
so what we do here is, a square we have got. Now we proceed to find out the inverse of a square. Okay,
Okay, sir.
so how to find out the inverse of a square? First we find the adjoint. Find the adjoint of a square. What is the adjoint of a square? Adjoint of 4 we write as it is. Okay, and now what we do is, what is the minor of this element, x plus 1? It is
X
x
plus
plus
1.
1.
Sir,
And
X
with what
plus 1.
sign? This is plus, minus, minus, plus. So with a plus sign, so no problem, x plus 1.
Minus plus,
Next,
sir.
what is the minor of this element? The minor of this element is 4 with a negative sign.
So 4
Okay. Next,
minus,
again, the minor of this element is x with a negative sign. And what is
sir,
the minor of
X
x plus 1?
negative sign.
It is x plus 1 with a positive
X
sign.
plus 1
And
with
whole thing
positive sign.
transpose. So this is 4 times
Transpose.
x plus 1 minus 4 minus x
Minus 4
x plus 1.
minus X.
Okay. So this is what you get, adjoint of a square. Now if what we calculate is determinant of a square. In fact, I should have calculated determinant of a square first. Okay. But okay, fine. Determinant of a square is 4 times the determinant of x plus 1 x 4 x plus 1. Okay. Now I check whether this determinant is not equal to 0. So how do I check? 4 times x plus 1 whole square minus 4x. Now what is 4 times x plus 1 whole square minus 4x? Expand, x square plus 2x plus 1 minus 4x. So you get 4 times x square minus 2x plus 1. So you get 4 times x minus 1 whole square. Right? So can this be equal to 0?
Yes, sir.
This can never be equal to 0. Why?
Equal
You
to
know,
0.
for x not equal to 1. See, x not equal to 1 is given here.
Yes, sir.
So that means only if x equal to 1, this can be
1.
0. So for
0.
this cannot be equal to 0 for x not equal to 1. If x is not equal to 1, this cannot be 0. Okay. So that means, therefore, a square is non-singular. Matrix A square is Non-singular.
Non-singular.
Therefore, A square inverse exists. Okay, I should have calculated the adjoint after this, but anyway, I've done it first. Okay, so adjoint of A square, and I know. So
Okay, sir.
what I have, therefore, what is A square inverse? Therefore, A square inverse is equal to 1 by determinant value of A square into the adjoint of A square. Okay, so determinant value of this is 1 by 4 minus 1 whole square, isn't it? And what is the adjoint of A
Yes,
square?
sir.
Adjoint of A square is 4 times 4 times
4
this
times x
matrix,
plus 1
x plus 1 minus x
minus x minus 4.
minus 4 and then
Sir, x plus 1.
x plus 1. This is the inverse. What you do is you cancel these two fours. So you simply get 1 by x minus 1 whole square into x plus 1 minus x minus 4 x plus 1. This is your inverse finished. Okay.
Okay, sir. Yes, sir.
So this is what you can do. This one was from your exams. Now find the sum of this and its multiplicative inverse. Now there's a note. Say this, see this 5b. We'll do 5b. Let me just erase this. Now multiplicative inverse, remember, inverse is also called as a multiplicative inverse. Understood? The inverse of a matrix is also called its multiplicative inverse. So if I say find the inverse
Multiplication
of,
inverse.
find the inverse of, I mean find the multiplicative inverse of. Okay.
Okay, sir.
So don't get confused with the name. Even if they say multiplicative inverse, even then you find out the inverse. But if they say additive inverse, then it is not that inverse. Okay, that I will do
Okay,
later,
sir.
what additive inverse means. But multiplicative inverse, see here 5b, the question is find the sum of this and its multiplicative inverse. So what I do is I say let a is equal to 2357. Okay, and
Okay, sir.
you need to find out the sum of a and its multiplicative inverse. Multiplicative inverse means simply inverse. So let us find the inverse first, then I will add with a. So what you do here is if I calculate det a first, det a is equal to 2357, which is equal to 14 minus 15, which is equal to minus 1, not equal to 0.
Minus
This
1.
means that matrix A is non-singular.
Non-singular.
Therefore, A inverse exists. Right? Now we proceed to find out the adjoint of A. Adjoint of A. What should be the adjoint? This here you have a plus sign, minus, minus, plus. Okay, so
Plus
minor of 2 is 7 with a plus sign.
7.
Next 3 is 5 with a minus sign. And next 5 is 3 with a minus sign.
Minus the
And
sign.
7 is 2 with a plus sign.
2 plus
And the
sign.
transpose of all this. So is equal to, what you get is 7 minus 5
7 minus 5
minus 3,
minus
2.
3. 2.
Okay, fine. Now we can find out the inverse. Therefore, A inverse is equal to 1 by det A into adjoint of A. Det A is 1 by minus 1. Minus 1 is det A, and the adjoint of A is 7 minus 3 minus 5, 2, which simply means that this is minus of this matrix. 7
Okay, sir.
minus 3 minus 5, 2. Now you multiply minus with each and every element in the matrix. You get minus 7 plus 3 plus 5 minus 2. So you're getting A inverse. Okay, so therefore
Yes,
what
sir.
is the sum of A and its multiplicative inverse? Therefore sum of A and its multiplicative inverse is equal to A plus A inverse, which is equal to, now simply see what is A, 2, 3, 5, 7, and its multiplicative inverse is minus 7, 3, 5, minus 2. So which is, you add up 2 minus 7 is minus 5. Okay, and 3 plus 3 is 6, 5 plus 5 is 10, 7 minus 2 is 5. So this is your sum of the matrix A and its multiplicative inverse. Okay, that is what you
Yes,
had to
sir.
do on number 5. Remember this, make a note here in your copies that inverse and multiplicative inverse of a matrix are the same, are synonymous. Okay.
Okay, sir.
Okay, find the inverse of the following matrix and verify the result. For the matrix X for which this. Okay, now see here, number 6. Number 6 is an important type of a problem. Okay, this type I have not discussed, but it would have been better if I had a 3 by 3 matrix. Anyway, we'll see. Let me discuss this type. Number 6. Find the matrix X for which. So given X into 3, 2, 1, minus 1 is equal to 4, 1, 2, 3. Also find the inverse of 4, 1, 2, 3. Now see, if you were in class 10, how would you have done this problem? You would have taken let X is equal to A, B, C, D, isn't it?
A, B, C, D.
And then you would have multiplied and then you would have solved
Yes,
the equations to find out A, B, C, D. But this time we'll not do it this
X,
way.
A, B, C, D.
This time we'll do it in a little, in a not little, in a much different way and a much easier way this time. What we are going to do here is see that X has been multiplied by this. Okay, that means first what you do here is you say let A is equal to this matrix 3, 2, 1, minus 1, and you say let B is equal to 4, 1, 2, 3. Okay, let I've assumed these two matrices. Therefore, what is the equation become? Therefore, XA is equal to B. Okay, now what you are going to do here is post multiplying both sides by A inverse. Post multiplying both sides
A inverse.
by A inverse if it exists. I haven't checked if it exists. Okay, so that is why I'm writing if it exists. So what happens? Post multiplying means XA into A inverse, right? Is equal to B into A inverse. Now what? I can write it this way: X A into A inverse is equal to B A inverse, because matrix multiplication is associative, isn't it? A
Yes,
B into C must be equal to A B into C. This is associative. But what is A into A inverse? A into A inverse is the identity matrix. I is equal to B A inverse. That means X into I will give you X back. So what is the value of
yes, sir.
X? A value of X is B into A inverse. That means if we simply find out the inverse of A, this matrix, if we simply find out the inverse of A and multiply it with B, I will get X. So what we do here is we proceed to find out the inverse of A. So first, in order to find out the inverse of A, we first find the determinant value of A. Therefore, what is det A? Det A is 3, 2, 1, minus 1. So you get minus 3, minus 2, which is minus 5. not equal to 0.
Yes.
That means matrix A is
Not even.
non-singular.
3 non-singular.
Okay, so that means therefore A inverse exists.
Okay, sir.
Now we proceed to find out the adjoint of A. Adjoint of A. So how will you find out the adjoint of A? Let's see what A here is. 3. This is the plus position, minus, minus, plus. Okay. So 3, the minor is minus 1 with a plus sign. So I'll
-1.
have a minus 1 here. Next, I have for 2, I have 1 here
So
with a
minus.
minus sign. So
Yes, sir.
minus 1,
Minus sign.
minus 1. Next,
So 2.
for
2 with
1, you
plus
have
sign.
a 2 with a minus sign. 2 with a minus
Yes,
sign,
sorry. Minus sign.
minus 2. And then finally, here for minus 1, you
3
have a 3 with a plus sign.
plus sign.
And do not forget to take the transpose. So you have minus 1, minus 1, minus 2, 3. So adjoint we have got. Therefore, we can find out A inverse. Therefore, A inverse is equal to 1 by det A into adjoint of A. Okay, and det A we have got minus 5. So 1 by minus 5 into the adjoint of A is minus 1, minus 2, minus 1, 3. Okay, so which means we can simply write it as minus 1 by 5 into minus 1, minus 2, minus 1, 3. Okay, so we've got A inverse. So what is the value of x here? The value of x here is x into x is equal to b into A inverse. So therefore, what is x?
Yes, sir.
Hence, x is equal to b A inverse. Okay, and what is b? B here
The
is
B
4, 1, 2, 3.
4 1 2 3.
4, 1, 2, 3. And A inverse here is minus 1 by 5
Minus 1 3 5.
into minus 1,
1
minus
minus
2,
1 minus 2
3.
minus 1 3.
So this you can write as minus 1 by 5 into these two matrices. 4, 1, 2,
1
3.
2 3 minus 1 2 minus 2 minus 1 3.
Now we multiply. So whatever we multiply, we get the value of x. Let's see what we get. First row, first column, minus 4, minus
Minus
1,
4.
minus 5. Next, minus 8, minus
Yes,
3. Sorry, minus 8 plus 3 is minus 5 again.
minus
First row, second column, right? Minus 8 plus 3. Next, second row, first column, minus 2, minus 3, again minus 5.
minus 5
And then second row, second column, minus 4 plus 9
plus 5
is plus 5.
minus 2 plus 5.
Plus 5. So if you multiply by minus 1 by 5, what do you get? You get a 1, you get a 1,
1
1, and
1
here minus 1.
1 minus 1.
So this is your x. Okay. But in class 10, back in class 10, what we used to do? We used to take x as
Use
A, B, C, D,
ABC.
and then we used to do it. But here we'll work out in a different way and in a better way. Okay. So this
Okay,
is
sir.
x is equal to B A inverse. Now what is the second part of the question? What was the second part? Which number? This was 6. Yes. So also find the inverse of 4, 1, 2, 3.
4 1 2 3.
So 4, 1, 2, 3. Let's finish this. Let's find the inverse. Here B is equal to this matrix. 4, 1,
4 1 2 3.
2, 3.
2
So
3.
let's find the inverse. What is det B?
That B is equal
4, 1, 2,
to
3.
2
So
3.
this is 12 minus 2, which
Yes,
is
sir.
equal to 10, not equal to 0.
10
That
not
means
equal to
matrix B
0.
is non-singular.
Non-singular.
That means B inverse exists. Okay. So let us proceed to find out the
B
adjoint
inverse.
of B. What is the adjoint of B? See here again. Plus minus
minus
plus.
minus plus
So minor of 4 is plus 3 with a plus sign.
plus
So, okay.
3
1 is minor of 1
minus
is
2
2 with
minus
a
2
minus sign. Minor of 2
minus 1
is 1 with
minus
a
1
minus sign.
minus
Minor of
plus
3
4
is 4 with a plus transpose. So this is 3 minus 2 minus 1 4.
minus 1 4.
This is adjoint. So therefore, what is B inverse? Hence, B inverse is equal to 1 by dead B into adjoint of B. Dead B we have found out as 10, and this is the adjoint. You leave your answer
Minus
here
2
as it is. So this is your inverse.
yes
Okay.
okay sir
So this is was your number 6. Let's see if there is any other problem worth doing. You can do number 7 on your own if you want. Okay. These are just
okay
practice
sir
problems, nothing else. Inverse, if you know how to find out, you can do all the problems. Find the inverse of the following matrices. Yes. Okay. Do number 10 3 I had given you last time. Try out number 10 2 and 10 3 both if you have not done. Okay. These are 3 by 3 matrices. One inverse of a 3 by 3 matrix I'm going to do with you right now. Okay. Because one 3 by
okay
3
sir
I have shown you that day. Okay. Today I will show you
yes
one.
sir
So, and just to refresh your memory once more, I'll show you. Let us do this. Number 14. 14 1. 14 1. 14 1. What is
1
given here? Given A is equal to 2 4 minus 1 minus 1 0 2, and B here is 3 minus 1 2 4 2 1. Okay, the question here is find out AB inverse. So first let us find out the product AB. Now you can do this in two ways. Okay. Uh, First, what you can do, let me show you the first method, and you can do the second method on your own. Okay, first method.
okay sir
You first find out, you have to find out AB inverse. So first find out the product AB. 2 4 minus 1 minus 1 0 2, and this is 3 minus 1 2 4 2 1. Find out this product. First row, first column. Tell me what should be the order of the resulting matrix. This is what? This is what order? 2 by 3, isn't it? And this is what order? 3 by 2.
बोल
Can they be
दिया
multiplied? Number of columns of the first
yes
matrix
sir
is equal to number of rows of the second matrix. Yes, they can be multiplied. And what should be the order of the resulting matrix? It should be a 2 by 2 matrix, right? So let's see whether we get a 2 by 2 matrix or not. Okay,
yes sir
let us multiply. So I have 2 into 3, first row, first column. 2 into 3, 6, minus 4, minus 2, right? First row, first column. Next, first row, second column is 8 plus 8, 8 plus 8 minus 1, right? Next, you have minus 3 plus 0 plus 4. And next, you have second row, second column, minus 4 plus 0 plus 2. Okay, so the matrix that you are getting here is 6 minus 6, 0, 8 plus 8, 16 minus 1, 15. And this is again, I think 1. And this is minus 4 plus 2 is minus 2. So product AB you are getting as this. So therefore, what should be AB inverse? Does AB inverse exist? We now proceed to find det AB. Det AB is
Yes, sir.
0, 15, 1, minus 2, which is 0 minus 15, which is minus 15, not equal to 0. That means matrix AB, matrix AB is non-singular, therefore AB inverse exists. Therefore AB inverse exists. Now we proceed to find adjoint of AB. Adjoint of AB is minor of 0 is, this is a plus position, minus position, minus position, plus position. So my minor of 0 is minus 2 with a plus sign, so minus 2. Minor of 15 is plus 1 with a minus sign. Minor of 1 is 15 with a minus sign. And minor of minus 2 is 0. It doesn't matter what the sign is. Transpose is equal to minus 2, minus 1, minus 15, 0. So therefore, what is A inverse? AB inverse? AB inverse is 1 by det AB into adjoint of AB. And det AB we have found as minus 15. Minus 15 times minus 2, minus 15, minus 1, 0, which is minus 1 by 15 times this matrix, minus 2, minus 15, minus 1, 0. And if you multiply minus inside, this will become 2, 15, 1, 0. So AB inverse, this we have found out by the first method, right?
Yes, sir.
AB inverse we have found out by the first method, this method. What you can also do is, if you want to apply the property, but this is going to be a little longer method. Second method, what you can do here is, you can use this property. AB inverse is equal to B inverse into A inverse. Okay, so you find, in order to find AB inverse, you first find out B inverse, and then you find out
B
A inverse, and then you multiply.
A inverse.
Okay, this method also you can do, but this is going to be a little long
Okay,
because
sir.
you have to find out inverse for both the matrices. Okay, so I stop here for today.